Hello everybody. So we'll be going through the second concept which comes under the second module, which is free body diagram. Already you went through the concept of equilibrium, the conditions of equilibrium, and also Lami's theorem in the previous video. And this is the next concept, which is free body diagram. And this concept is very, very important. Very important. You'll be drawing the free body diagram. Free body diagram is a drawing. You'll be drawing the free body diagram initially in all the numericals, and with the help of free body diagram, you'll be analyzing or you'll be solving the numericals. So this concept is very important as far as this particular module is concerned. So free body diagram is a drawing. Is basically a drawing which you draw in order to represent all the forces acting on a particular body or on a given arrangement. You'll be drawing all the forces separately and systematically. You'll be drawing all the forces separately and systematically, which acts on a particular body or given arrangement, which acts on a particular body or given arrangement separately. And we call that particular drawing as free body diagram or FBD. So free body diagram is basically a drawing which represents all the forces very systematically, so that you can use that particular drawing to determine a particular aspect which is being asked, or to solve a numerical, or to analyze a force system. Basically, free body diagram is a drawing. It's a drawing which represents all the forces acting on a particular body. So all the forces, in the sense, there are two types of forces which acts on a particular body. The first type is external force. External forces. There are a number of forces, or there might be a number of forces acting externally on a body. And the second type is the hidden forces. You have two types of forces acting on a particular body, and in free body diagram we'll be determining both external as well as the hidden forces. We'll draw it separately and systematically so that it can be analyzed easily. Now let us try to understand the procedure to draw free body diagram. Procedure to draw the free body diagram. In order to understand the procedure, let me consider an example. Where you have a surface, vertical surface. Let me consider this as a vertical surface, and a string, and a circular object or body. So this is the surface. This is the string, and this is the object or body, which is circular here in this particular example. Now, for body is in contact with the surface. Everybody observe here carefully. Body is in contact with the surface with the help of the string. The string holds the body, or body is being tied or it's in contact with the surface with the help of a string. This is an example which we have considered here. Now, to understand the procedure to draw the free body diagram, this is an example. Now, this particular body is in contact with the surface, and let me mark the point of contact as A. Let me write it on the other side. Point of contact as A. So, hope you have understood the arrangement. We have a body, we have a surface, and we have a string. Body is in contact with the surface with the help of string. This is the considered example or considered arrangement in order to understand the steps to draw the free body diagram. So there are no external forces. I have not considered any of the external forces acting on the body. If you have an external force, let us consider it later. Now this is the given arrangement, and step number one in drawing the free body diagram is to identify the center of the given object or body. Center will be given. Let me mark the center as well in order to identify the center. Step number one is to identify the center of the given body or the object and to draw the coordinates. and to draw the coordinates with respect to the center. You're supposed to identify the center of the given body or object. This is a circular body here or an object. You're supposed to identify the center and draw the coordinates. Draw the coordinates with respect to the center, x and y axis. Draw the coordinates. Yeah. So this is step number 1. Step number 1 is to identify the center of the given object or body and to draw the coordinates. Step number 2. Step number 2 is to draw the self weight, mark the self weight. Self weight of the body or self weight of the object given is to be marked in step number 2. And self weight will always be acting vertically downwards. Self weight will always be acting vertically downwards. Self weight should always be marked vertically downwards. So step number 1 is to draw the coordinates. Step number 2 is to mark self weight. Which always moves vertically downwards. Step number 2 is to mark self weight which always moves vertically downwards. Step number 3 is to mark the reaction offered by the surface. So whenever a body is in contact with the surface, surface offers a reaction on the body. Whenever a body is in contact with the surface offers a reaction on the body, and we call that reaction as normal reaction. And step number 3 is to mark the normal reaction. Or reaction offered by the surface. And this is how we are supposed to mark. This is the vertical surface here. And reaction offered by the surface will always be perpendicular to the surface. Reaction offered by the surface will always be perpendicular to the surface. Reaction offered by the surface will always be what? Perpendicular to the surface. And reaction offered by the surface will always be directed towards the body. Direction of reaction will always be directed towards the body. And it will always act at the point of contact between the body and the surface. So this is normal reaction. Let me write it as R. Step number 3 is to mark the normal reaction. I'll again repeat. Step number 3 is to mark the normal reaction. How to mark the normal reaction? There are some important rules to mark the normal reaction. Normal reaction should always be perpendicular to the surface. And should be directed towards the body. And it should act exactly at the point of contact between the body and the surface. In this case, it is A. Got it? Normal reaction is to be marked by following these 3 rules. Normal reaction should always be perpendicular to the surface, not the body. Normal reaction should always be perpendicular to the surface, directed towards the body, and it should act exactly at the point of contact between the body and the surface. This is the reaction offered by the surface on the body when the body is in contact with the surface. This is step number 3. Now, step number 4. Step number 4 is to mark the reaction, the tension along the string. That's a string, is it not? This particular string holds the body, or with the help of this particular string, the body is in contact with the surface. So there is a tension or force which runs through the string. And in step number 4, you'll be marking the tension which runs through the string. And tension which flows through the string is always away from the body. Step number 4 is to mark T, tension T. And tension T will always move away from the body. Tension T will always move away from the body. Whereas normal reaction, which you mark in step number 3, always moves towards the body. Tension T always moves away from the body. So you have marked 3 forces, W, R, and T. So these are the 3 hidden forces. These are not the external forces. These are the 3 hidden forces. Step number 1 is to draw the coordinates. Step number 1 is to draw the coordinates by identifying the center of the object. In step number 2, you'll be marking the self weight. Self weight of the body or object will always move vertically downwards. And in step number 3, you'll be marking the normal reaction. Normal reaction has a number of conditions to draw. Normal reaction will always be perpendicular to the surface, directed towards the body, and it will act exactly at the point of contact between the body and the surface. And in step number 4, you will be drawing or marking the tension through the string, and tension will always be marked away from the body. These are the 3 hidden forces which you're supposed to mark. So if you have an external forces, it will be directly given in the problem. These are the 3 hidden forces which you're supposed to mark. So once you mark all the hidden forces, you have to, step number 5 is to draw only the coordinates and forces. Step number 5 is to draw only the coordinates and forces systematically by bringing all the forces to the center, and making it a concurrent force system. So you have to draw only the coordinates and the forces. This is the coordinate. You have 3 forces, W, R, and T. So you have to draw it separately by bringing all the 3 forces to the center. Let me draw it. Step number 5 is to draw only the coordinates. I'll draw the coordinates. These are the coordinates, X and Y. And I have to draw all the forces separately. By bringing them to the center. Center is O. By bringing all the forces to the center. So I can draw self weight here. So this is the self weight W. And I can draw the normal reaction. Normal reaction can be drawn either here in the negative X scale or in the positive X scale. The original position of normal reaction is here in the negative X scale. I'll be applying the principle of transmissibility and I'll be pushing it to the positive X scale so that it becomes concurrent, normal reaction. And where can I draw the tension? Tension can be drawn in the second quadrant. Tension T can be drawn in the second quadrant. So it makes an angle, which is unknown. So how many forces did we mark? We have marked W, R, and T. We have marked the 3 forces, W, R, and T. And all the 3 forces are concurrent. I have brought all the forces to the center, just reproducing the coordinates and all the forces. By bringing all the forces to the center will be step number 5. And this particular drawing, what you have drawn, is called as free body diagram. So in a free body diagram, all the forces will be concurrent. Because you bring all the force to the center and you draw it systematically. So you have identified 3 hidden forces, W, R, and T. And in step number 5, you bring all the 3 hidden forces to the center. You draw it along with the coordinates. Or you have to reproduce all the forces which I have drawn using blue ink. So the coordinates W, R, and T is to be reproduced systematically in step number 5. And what you draw in step number 5 will be the free body diagram. This is the free body diagram of the given arrangement. Hope all the steps are clear. Step number 1 is to draw the coordinates by identifying the center of the object. Step number 2 is to draw the self weight. Self weight moves vertically downwards. Step number 3 is to mark the normal reaction offered by the surface. Surface offers normal reaction whenever a body is in contact with the surface. And normal reaction offered by the surface should always be perpendicular to the surface, should be directed towards the body, and should be acting exactly at the point of contact. Step number 4 is to mark the tension. Tension always moves away from the body. Whereas normal reaction always moves towards the body. So once you mark all the forces in the given arrangement, you have to reproduce only the coordinates and forces. Systematically by bringing all the forces to the center. So obviously self-weight W originates from O. The original position of normal reaction somewhere here in the negative X scale. Use Principle of transmissibility to push it to the positive X scale, and you can draw the tension which originates from O itself. So now we have three forces, W, R, and T, which originates at O. O is the common point. Now all the forces are concurrent here, and this is the free body diagram for the given arrangement. You had an arrangement initially. Now we could draw the free body diagram with the help of the initial arrangement. The initial arrangement. So here you have arranged all the forces, and this particular drawing is called as free body diagram. Free body diagram, and these are the 5 steps which are supposed to follow in order to draw the free body diagram. So this particular concept is very, very important to solve the numericals. So try to understand this. If you have any doubts, you can contact me anytime. Thank you.